Manticores are Persian mythical creatures that have the body of a lion, the wings of a dragon, and the tail of a scorpion. The tail is also quill-like in many depictions. In manticores, a red mane is dominant to a yellow mane, big wings are dominant to small wings, and a normal tail is dominant to a scorpion tail. Let's say that a manticore with a red mane, scorpion tail, and big wings mates with a manticore with a yellow mane, normal tail, and small wings. It will produce an F1 offspring with these chromosomes. This manticore will have a red mane, normal tail, and big wings. During meiosis, the F1 offspring creates 8 different types of gametes that it can pass on when it mates. These are the gametes that can result in meiosis. We can first identify the gametes where no crossover occurs because they will look the same as the chromosomes of the F1 manticore. So that'll be big R, small t, big W, and small r, big T, and small w. And those are NCO. Then let's just go down the list. We have big R, big T, and big W, which means that we have to have 2 crossovers to get this combination. Same goes for small r, small t, and small w, so these are our double crossovers. Here we have a big R, small t, and small w, so we will have to cross over at the second site to get the small w. Same goes for small r, big T, and big W. There would have to be a cross here in order to get the big W, so these are SO2. And finally, we have big R, big T, and small w. We would have to cross over at the first site to get this gamete and the small r, small t, and big W, so this is SCO1. We know that the map would look like this, where the R and T alleles are 15 centimorgans apart and the T and W alleles are 22 centimorgans apart. The coefficient of coincidence is given as 0.84. With this, we can find the probabilities of each of the events occurring. The probability of the double crossover event occurring is calculated with this equation. R1 is the distance between the R and T allele, while R2 is the distance between the T and W allele, and C is the coefficient of coincidence. When we take those values and plug them in, we get 0.02772 as the probability of a double crossover event occurring. This probability is for getting big R, big T, and big W, and little r, little t, and little w. But what if we only want the probability for one of the gametes instead of both? That's simple. Just multiply by 1/2. When you do that, you get 0.01386 as the probability for one of the gametes being produced. Now let's try to calculate the probability of a single crossover event at the first loci occurring. To calculate this, we take R1 and subtract the probability of the DCO event, which, recall, was 0.02772. What is the probability of getting a gamete with a big R, big T, and little w?